Welcome you all to Sadvidya Academy Science Classes by Ganesh Abbar. So today's topic is Class 10 Physics, Chapter number 12, Electricity Part 1. So before starting the actual class, we shall see which are all the topics which we need to cover in this particular chapter. First topic which we cover is meaning of current. Next, electric current and circuit, electric potential and potential difference, circuit diagram, Ohm's law, factors on which resistance of a conductor depends on, resistivity, resistance of system of resistors, heating effect of electric current, practical applications of heating effect of electric current, and electric power. These are all the topics which are needed to be covered in this particular chapter. So we should start all these concepts one by one. First, before knowing about what is electric current, we have to know the meaning of the word current. What is mean by current? What is mean by current? If you search in the dictionary about the meaning of electric current, or else if you search in the dictionary about the meaning of the general meaning of current, it says that the flow of something. Flow of something is called as current. In general meaning, flow of something is called current. So for example, if water is flowing, flow of water in a river, so it is called as water current. Similarly, sometimes the air flows continuously in the atmosphere, so that we call it as wind current. That is wind current. Or sometimes ocean currents also, we use ocean currents for the flow of water in an ocean. So that means in all the above examples which I have quoted, such as water current, wind current and ocean current, something is flowing, right? So in this particular chapter of electricity, we are going to discuss about the concept of electric current. So what is the matter which is flowing here in electric current? It is nothing but, so that the name itself indicates, it is electric current. So the name itself indicates it is electric. What is electric? It is the flow of electrons in specific, or in general. We already know that electrons are the charged carriers, or we call them as electrons, protons and neutrons. We call them as charges. So in general we can say the electric current is the flow of charges. In your previous classes you have discussed about these charges in detail, about the structure of the atom and all that. So I'm not going to discuss about the charges here. So flow of charges is called as a current. Flow of charges is called as, in specific it is called as the electric current. We know that if there is a torch, if the bulb needs to be glow, or bulb glows, then that means the switch is on. Then what is the action of a switch? What does the switch do? Switch makes a conducting path conducting path for the movement of charges. For the charges, it makes a continuous conducting path for the movement of charges. So now we know that electric current is the flow of charges. Now the question may arise, what are charges? So next concept we are going to discuss is about what are charges. So what is a charge? What is mean by a charge? It is nothing but it is a property of any matter. It is a property of any matter. It is a property of any matter. Same as every matter will have mass, right? There will be mass if this is a matter. If we consider this as a matter, it has some mass m. So if someone asks you what is mass, it is nothing but a property of that particular material or that matter. In the similar fashion, along with the mass, there is one more property called as the charge. So what is mean by a charge? It is a property of any matter. So, but mass is only one kind. So this much kg, we use the word this much kg. There is no concept of positive and negative mass. But we are going to discuss about the charges. When we discuss about the charges, we have already studied there are two kinds of charges. There are two kinds of charges. So what are these? These are positive and negative. So these are nothing but the properties of every material to have some charges. Either it may be positive or it may be negative. So, say for example, if in any atom, if you consider, you have studied in your previous class about the atomic number. In that it says that the number of protons and number of electrons in any atom are same. So we already know that protons and electrons are the charges. We have studied protons are positively charged and electrons are negatively charged. So there are two types of charges we have already told you, that is positive and negative. So protons are positively charged and electrons are negatively charged. In any atom, if we consider, the number of protons and the number of electrons are always same. So what happens to the net charge of an atom? Net charge of an atom is always equal to 0. So we say that an atom is electrically neutral. We say that an atom is electrically neutral. So, and there is one more particle inside the nucleus which is called as the neutron, that is also electrically neutral. So in this particular slide we have discussed about what are charges or what is mean by a charge. Charge is nothing but it is a property of any matter. But this charge might be positive or else it might be negative or it might be neutral. There are mainly two kinds of charges. Then if there is no charge at all, then we call such a body as electrically neutral. It does not have any charge. So I hope you have understood about the concept of what is a charge. So next thing is, if we know what is a charge, then how to find it? In order to measure any physical quantity, there must be some unit. Say for example, if I ask you, what is your mass? You say that your answer will be this much kg. That kg refers to the SI unit of that particular mass. Then what unit we can use to represent a charge? Which is a unit we can use? That is nothing but a SI unit of electric charge. It is named after a scientist called as Coulomb. So it is nothing but Coulomb. And its symbol is the capital letter C. It is a SI unit of the electric charge. It is SI unit of electric charge is Coulomb. How we denote mass in terms of kg. Similarly, Coulomb is a unit which is used to measure a charge. So, Coulomb, it is represented by the letter capital C. So, always a charge will not be equal to this many coulombs. Say for example, 1 coulomb of charge, it is a very large unit. Very small units of charge, how to denote smaller units of charge? In order to represent smaller units of charge, we use some other terms. That is, say for example, we use millicoulomb, or we use mc, which is equal to 10 to the power minus 3 of a coulomb. That is 10 to the power minus 3 coulomb. It is called as millicoulomb. Similarly, there is one more quantity which is called as microcoulomb. Micro means we have already studied 10 to the power minus 6 of a coulomb. Or sometimes nanocoulomb is also used. It is 10 to the power minus 9 of a coulomb, These are all some of the prefixes which we use: micro, nano, milli, etc. These are all the prefixes which we use in order to represent the smaller units. So, knowing this, the SI unit of the electric charge, we also have to know about which is the symbol used to indicate the charge. Charge is indicated, charge in any atom is indicated by the symbol either capital Q or small q. Charge is represented by the letter Q. Sometimes small q is used, sometimes capital Q is used. So Q is the symbol which is used to represent a charge. Don't get confused here. Coulomb is the SI unit of charge and Q is the symbol which we represent to identify, or in order to represent a charge we use capital Q or small q. That clear? I hope the concept of the SI unit of electric charge and their smaller units is clear to you. Next, moving on ahead with the next concept, that is definition of 1 coulomb of charge. So what is the definition of 1 coulomb of charge? When the charge will be 1 coulomb? So we know that we define the charge of an electron as negative. We already have defined the electron is negatively charged, but we didn't specify how much negativity is, how much negative that electron's charge is. That we have not told till now. So the charge of an electron is minus 1.6 into 10 to the power of minus 19 coulomb. This much small is the unit of an electronic charge. Remember, it is minus 1.6 into 10 to the power of minus 19 coulombs. That is the charge of an electron. We represent it by the letter small e. That is, this is the letter which we use to represent the electronic charge. So it is minus 1.6 into 10 to the power of minus 19 coulombs. Now, our aim is to define 1 coulomb of charge. So we can directly define 1 coulomb of charge. How? In order to form this much coulombs of charge, how many electrons are needed? 1 electron is needed. That means 1 electron means how many coulombs? Minus 1.6 into 10 to the power of minus 19 coulombs. Look at this number. It is very small, writing 1.6 divided by writing 1 upon 19 zeros in the denominator. That much small is this number. So for 1 electron, it will be minus. For the time being, we don't represent the minus. We require only the magnitude. That's why we represent 1.6 into 10 to the power minus 19 coulombs. So how many electrons are required to form? How many electrons are required to form how much coulomb? 1 coulomb of charge. In order to form a charge equal to 1 coulomb, how many electrons are required? Just you cross multiply that, so that 1 into 1 electron divided by this 1.6. So I can write, so number of electrons required to form 1 coulomb of charge is given by, which is equal to 1 into 1 electron, that is 1 into 1 coulomb, divided by 1.6, that is 1 by 1.6 into 10 to the power of minus 19. That much number of electrons are required. If I take this, if I simplify this, it will be 1 by 1.6 whole into, when this 10 to the power minus 19 goes to the numerator, it becomes into 10 to the power plus 19. So what is the value of 1 by 1.6? That is nothing but 0.625 into 10 to the power 19. But in order to represent in 6.25 something, that when we take the one decimal point towards the right, it becomes 6.25 into 10 to the power of 18. It is 6 point, remember. So that particular value is 6.25 into 10 to the power of, so I will write once again. So it is 6.25 into 10 to the power of plus 18 electrons. That many electrons are required to form a charge of equal to 1 coulomb. So how to define 1 coulomb then? Now how to define 1 coulomb of charge then? So the definition of 1 coulomb, it is the charge contained by how many electrons? As we have seen earlier, it is a charge contained by 6.25 into 10 to the power of 18 electrons. That means it is a charge constituted or contained by 6.25 into 10 to the power of 18 electrons. Look at that number, 10 to the power of 18 electrons. So I hope you can visualize that number, 6.25. You have to write 6.25 in front of which, into how many times you have to make 10? Into 10 into 10 into like that. 18 times you have to multiply it by 10. At that time, whichever the very large number you will get, that much number of electrons are needed to form a charge which is equal to 1 coulomb. That is how to define 1 coulomb of charge. So how to define 1 coulomb then? It is a charge contained by 6.25 into 10 to the power of 18 electrons. Or in other words, I can also say, or the one more definition I can say, it is the charge constituted by 6.25 into 10 to the power of 18 electrons. Then such a charge is said to be equal to 1 coulomb. So knowing about the charge equal to 1 coulomb, we shall move on to the next concept. The next topic which we have to discuss is about what is an electric circuit. What is an electric circuit? The definition of electric circuit is it is a continuous and a closed path. It is a continuous, it should be continuous, and it should be closed path. There are two conditions. Which are they? One, it should be continuous path, and one more, it should be closed path of what? Of an electric current is called as an electric circuit. It is shown in the diagram below. So it is nothing but you can look at this particular diagram here. It starts from here, this point. That particular diagram starts from this point, and the arrow marks show the path and all this, and it ends at the same point. So that is why it is a closed path. What is the meaning of closed path? It is nothing but it should be starting from the same point and it should be ending at the same point. That is the meaning of closed. And what is the meaning of continuous? There should not be any breaks in the path. Is there any breaks in the path? No, it is a continuous path of what? The electricity is flowing in this. So of electric current. So you can look at different apparatus here. This is the bulb, and this is an instrument used to measure the current, that is called as an ammeter, and this is a device, or we call it as a switch or a key. Switch or key we call it as, and this is nothing but the symbol of a battery. These all these symbols we discuss in the later sessions. So these are all different circuit diagrams. This is the symbol used to measure bulb, and all these ammeter, key, etc. And what is the purpose of a switch or a key? It is used to switch on and switch off the circuit. What is the meaning of switching on and switching off? So it is making some discontinuity in between the path. So it makes discontinuous path. At that time the current will not flow. So it will allow a closed and continuous path to the flow of charges. That is the purpose of a switch. So this is nothing but a rough diagram of an electric circuit. The next thing what we have to discuss is about the electric current. Mainly first thing we have to discuss is about the definition of electric current. In general we have discussed what is current, that is a flow of something. But what is the meaning of electric current, or how to find out the electric current? Yeah, it is nothing but the flow of electric charges. But how to find out that? How to find out how much current is flowing in a circuit? So that we discuss in this particular topic. So definition of electric current. Say for example, if you consider a circuit. Say for example, there is a circuit, or I will consider only a wire, a copper. Let us assume that this is a copper wire. And if I have kept some person here to look after that particular wire, so that he is continuously counting, that person standing here is appointed so as to count the number of electrons or the charges flowing in this particular wire. So what is his duty? He is counting, he is sitting here, he is standing here and looking at his watch and calculating how many number of charges are flowing through this particular cross section. This is nothing but some area I have considered for my consideration. Through this particular area of cross section, how many electrons flow per unit time? That means per second he is calculating. That means, so some people in childhood, we used to have the habit of counting the number of vehicles passing through the road. In a similar fashion, it is the same thing. So he has to count. He is given with some electron microscope or something. Why? Because we can't find out the charges in our naked eye. That is why he is given with some electron microscope or something. So his duty is to keep on counting the number of charges flowing through the circuit. So, and he has to give me the report. How many electrons? I will give him, say for example, 1 minute of time. I'm giving him 1 minute. That means 1 minute, that means 60 seconds of time I'm giving, and he has to calculate how many charges are flowing. So we already know that Q is the symbol for representing the charges. Let us suppose that he has started his stopwatch and he's counting the number of charges flowing to that particular area in a given time. Given time is 60 seconds. Let us assume that Q be the amount of charges flowing in that particular area. So let us assume the any Q, value of Q, it may be very large value. So what is the time he is taking? He is taking, say for example, T is the time. I don't consider it as 1 minute. So in general, I am taking T for the time interval and Q for the charge. So that is nothing but Q is for the charge, number of charges flowing through that area per unit time. If he calculates and he takes the ratio of the charge to the time, then that itself will tell us at how much rate the charges are flowing, or I will get the rate of flow of charges. That rate of flow of charges itself is called as the current. So that itself is called as a current, which is represented by the letter capital I, remember. So rate of flow of charges. How to define something which is written in rate of something? That is that something divided by time. That is the meaning of saying time rate of something. Time rate of something means that something divided by time. So what is something here? That is nothing but rate of flow of charges. So that means amount of charges flowing divided by the time. That is called as charge, ratio of charge flowing through the given area per unit time. That ratio we call it as the current. Then, so that what is the definition of electric current then? Electric current is expressed by the amount of charges flowing through a particular area in unit time. That is the meaning. What is, if I divides the total number of charges divided by the time, whatever I will get the number of charges flowing per unit time, is it not? So if say for example Q amount of charges are flowing per a given time T, then Q by T, what does it give? It will give number of charges flowing per unit time. I hope you have understood. So Q by T. Or in other words, one more definition of current is, it is the rate of flow of electric charges. It is the rate of flow of electric charges. That is the definition of electric current. Then what is the SI unit? Next thing, in the next slide, what we are going to discuss is about the, in this slide we are going to discuss about the SI unit of electric current. What is the SI unit? So while telling about the charges, I have already told you it is coulombs. Coulombs is the unit which is used to measure the charges. But to represent the current is, we already know that current is represented by the letter I. We don't represent C for current, we represent it by the letter I, which is equal to the charge divided by the time. Charge divided by time, which is equal to Q by T. So here Q is nothing but, what is the SI unit of Q? Q is nothing but coulomb. SI unit of charge is coulomb divided by time. SI unit of time is, it is second. Coulomb by second, or I can write it as coulombs per second. This coulombs per second itself is called as, there is a separate name for that, coulombs per second. The whole thing is represented as ampere. It is a new term which you come across, that is ampere, which is represented by capital letter A, remember. So it is not small letter a, it is a capital letter A, that is coulombs per second. Or we won't use this coulomb per second many times. Much of the time we use the ampere, that is the SI unit which is used to measure the current. Then here our aim is to define that. Then when this ampere or that SI unit of current will be equal to 1 ampere, when will be the current, when will be the current equal to 1 ampere? That itself is the definition of 1 ampere. So they may ask you, when will be that current flowing through the circuit is 1 ampere, or define 1 ampere. How to define 1 ampere? It is, can you define by looking at this particular formula? Actually, the formula of 1 ampere hides in this particular formula. That is, we know that I is equal to Q by T. I should be equal to 1 ampere. When it is possible? It is possible only when the Q is 1 coulomb and the time is 1 second. At that time 1 by 1 is 1, that is equal to 1 ampere. So what is the meaning of that? What is the meaning of saying 1 coulomb divided by 1 second? That is the formula or the definition of current is, so I will erase this. So definition of current is, how to define current? That is nothing but when 1 coulomb of charge flows through a conductor in 1 second, then the current is said to be 1 ampere. Same. Say for example, I will write it in small letters here. That is I will be equal to 1. When it is possible? When Q is 1 coulomb. So that 1 coulomb of charge should flow in how much second? In 1 second. Then it becomes 1 coulomb per second, or which is equal to 1 ampere. The same is defined here in words. So when 1 coulomb, look at this particular statement, when 1 coulomb, it is written here, 1 coulomb of charge flows through a conductor in 1 second, flows through a conductor in 1 second, then that current flowing through the circuit is said to be 1 ampere. That is 1 coulomb of charge flowing in 1 second, then the current is said to be 1 ampere. That is the definition of 1 ampere. So we have defined about 1 ampere already. So what is the definition of 1 ampere of current? When 1 coulomb of charge flows through a conductor in 1 second, then the current is said to be 1 ampere. Then what is the apparatus which we use to represent the flow of current? There should be some measuring instrument, right? Say for example, we use the mass using the weighing machine, or we use the temperature of our body using the thermometer. In a similar fashion, there should be some instrument to measure the amount of current flowing through the circuit, right? In our say for example, in your water supply, so corporation water which is coming into your home, they will fix a meter. So how much water you have utilized? So that means it calculates the total amount of or the volume of water you have consumed. In a similar manner, in order to calculate, in order to find out how much current is flowing through a particular conductor, then there is an instrument called as an ammeter. There is an instrument called as an ammeter. Ammeter is a device. What is ammeter? They may ask you, or they may ask you which is the device used to measure the current. A device which is used to measure the current flowing through the circuit. Current flowing is called as an ammeter and is indicated by the symbol like this, and here positive and negative. That is the symbol of an ammeter. And remember, it is used to measure the amount of current flowing through the circuit. That is why it is always connected in series. It is always connected in series in a circuit. You will study what is the series and what is parallel combination of connecting any electronic gadgets. So in your combination of resistors, there you will study what is series combination and what is parallel combination. The next topic which we need to discuss is so we have already discussed 1 ampere is a current constituted by the flow of 1 coulomb of charge in 1 second, or the one more definition of 1 ampere is it is a charge constituted by the flow of 1 coulomb of charge in 1 second. That I have already explained it to you. So if you find the first definition to be difficult, you can use the second definition also. That is, 1 ampere is the current constituted by the flow of how many charges? 1 coulomb of charge in 1 second. That means in 1 second, if 1 coulomb of charges flow through a conductor, then the current flowing through the conductor is said to be 1 ampere. Next concept which we are going to discuss in this particular chapter is how many electrons are required to form a current equal to 1 ampere. Then how many electrons are required? As we have already studied, 1 ampere is nothing but it is a flow of 1 coulomb of charge in 1 second. But we know that in order to form 1 coulomb of charge, how many electrons are needed? That is 6.25 into 10 to the power of 18 electrons are needed to form 1 coulomb of charge. That many number of electrons should pass through a conductor per second, remember. Then that current is said to be 1 ampere. So in other words, can you define the 1 ampere in one more sentence in the other way around? That is, that means 1 ampere is the current flowing when 6.25 into 10 to the power of 18 electrons flow through the conductor, in 1 second. That is one more definition of the 1 ampere. So they may ask you, sometimes they may also ask you how many electrons constitute 1 ampere. So that is equal to 6.25. Remember there is a point here, 6.25 into 10 to the power of 18 electrons constitute 1 ampere. That much number of electrons should pass through the conductor in 1 second. Then the current flowing through the conductor is said to be 1 ampere. So let us sum up all the things which we have discussed in part 1. So we shall sum up the concepts which we have discussed in part 1 of this lesson. So we have discussed about the meaning of the word current. It is the flow of something. Or what is mean by a charge we have discussed. It is nothing but a property of every material. And SI unit of charge is, it is nothing but coulomb. And in order to represent smaller units, we use micro and millicoulombs. Micro means 10 to the power minus 6 coulomb and millicoulomb means 10 to the power minus 3 coulomb. And definition of 1 coulomb of charge we have discussed. It is a charge constituted by 6.25 into 10 to the power of 18 electrons, that we call it as 1 coulomb of charge. Then definition and formula of current. What is the definition we have discussed? It is the rate of flow of charges and the formula is The formula for current is current I is equal to Q by T. This is a formula for current, and SI unit of current we have discussed. It is nothing but ampere is the SI unit of current. Next concept we have discussed is the definition of 1 ampere. It is a charge constituted by the flow of 1 coulomb of charge in 1 second. Then it is called as 1 ampere. Then the instruments used to measure current is called as an ammeter. Ammeter is a device used to measure the current. And that's all we have discussed in part 1. Thank you.